Hello, welcome back to another episode of CSC 263 Database Management Systems. We'll continue looking at the structured query language, and in particular, today we'll be looking at aggregate functions. In the previous video, we talked about how we can retrieve data from a single table. And that is basically the retrieval of data we put in there at some time in the past, and whether we want to retrieve everything that's in this table or we want to make a selection or a projection or maybe a combination of both, that's out for the discussion. But what we really only discussed so far was simple store and retrieve. Today we're going to look a little further and we're going to look at the use of aggregate functions. So what is an aggregate function? Well, the name kind of says it already. It is a function that applies an operation to an aggregate. So we're not going to retrieve values from the database the same way that we're putting them in. We're going to apply an operation to them. And so we could have different kinds of operations. For example, we're going to calculate maybe the sum of all sales in our database. How much money did we make by just looking at sales? That is useful, but what's probably even more useful is having the ability to first carve up the data that we're interested in analyzing into, say, different categories or different buckets or maybe different groupings, and then apply that aggregate operation to each of those groupings. For example, let's say that I have my database with all my grades in there, the same one that we have been looking at so far. And I want to know how well the students are doing in each course. And that would, for example, be a way to calculate the average grade per course. So the grouping would first be, let's put all the records pertaining to a specific course together. And then for all of those records in that grouping, we're going to calculate the average. For another course, we're going to calculate a different average. And our final result would then be, the grouping for CSC 263, on average, people got an A-. For CSC 280, people got also an A-. For 381, maybe it was a B+. But so now we have per grouping a result. Other could be things like the lowest price per product category. So now first I'm going to group all of my products by their product category, and then I'm going to apply the aggregate operation, the lowest or the minimum value, to each of those categories, and I can look at those results. Or maybe we want to calculate the grade point average for each student. That means that I group all of my, in this case, grades by student, and then I'm going to calculate an average based on the points that they scored. All of those are aggregate operations. Now, because we're only applying the operation on an aggregate, the aggregate or the field by which we aggregate is the only thing that we can return from a query like that. So let's take a look at our, for example, our grades table again, where we had course ID, student ID, grade, term, and the date posted. If I am going to aggregate by course ID, then the course ID is the only value I can retrieve back from my database. And that makes sense because I've basically gotten rid of all of the other subfields by aggregating on the course ID. In addition to the course ID, the one that I'm aggregating by, I can also return the value of the aggregate operation applying to that grouping. So if we're going to create one of those aggregate functions, well, first of all, is you have to recognize that you are. But when you talk about functions like minimum, maximum, sum, average, standard deviation, those are almost always aggregate operations. The first thing then is going to figure out how do we need to group our fields. So determine your grouping. The second part is then what operation do I need? And then the last one is how to write it in proper SQL syntax. The example is listed here. For example, I may be interested in the number of grades posted for a particular course. Notice that this is not the number of distinct grades. This is the overall number of grades posted for a course. So that would be my query. What is the number of grades posted for each course or per course? And when I hear that per or that for each, now I immediately identify that's my grouping field. So we're going to use the group by statement for that. Course ID in this particular case. What are we calculating? Well, the number, the count of the number of the grades. So the course ID, the number of grades per course ID from the grades table. And then I'm also going to ask them to be ordered. Remember, if I don't specifically say in my query how I want my results sorted, they may appear different each time, because in a relational database, the rows are not sorted by default. You have to say how they were sorted. And in this case, I want them listed by course ID, ascending, so going up, which means that the lowest course ID goes first and the highest course ID goes last. And this is my aggregate function. Some of the aggregate functions that we can use include these: the average, the count, max, min, and the sum. These are the most commonly used, the easiest ones to use. Notice we have this distinct keyword. We counted the number of grades, overall number of grades. If we wanted to only have the unique grades, how many different grades, uniquely different grades, we can use the keyword distinct in there as well. The aggregate operation understands distinct also. So having said that, let's go take a look and see what these aggregate functions mean in practice and how we do them, how the database deals with them. Let's take another look at our database schema. In this particular case, I am looking to answer the question what the average grade per course would be for the fall 2019 semester, and I want that sorted by grade in such a way that the highest average is listed first and the lowest average is listed last. So there's a couple of things we have to figure out there. First, we have to restrict all of our computations to only those courses or those grades that awarded in the fall of 2019. Then we'll have to go group them by course, because we're looking at the average grade per course. Then we have to calculate the average for each of those courses, and whatever comes out of that we'll have to sort. Now, when we look at the grades table at the moment, we see that we have 5 fields in there: student ID, course ID, term, grade, and posted. And there's an issue right there. If I want to calculate an average, I need to have a numerical field, and at this point grade is not a numerical field, it is a character field, and therefore I cannot calculate an average. So I'll have to go extend my schema to allow that. So let's take a look at how we could do that. First, we look at the schema up here, which would be student ID, course ID, term, grade, and posted, with the different data types there. The easiest way to extend this is by adding an extra field that captures the grade not only as a letter grade, but also as a grade point field. We know, for example, that if you get an A, that gives you 4 points. If you get a B, that gets you 3 points, etc. Now, since we can deal with things like A plus, A minus, C plus, C minus, we cannot use an integer field there, so we have to use a floating point field. And so by simply extending our schema with that extra field and then computing for each of the grades in our database what the numerical equivalence would be, we can move towards being able to do this calculation. And this is how we could do that, by just adding the points field as a float. Note, if we do that though, we introduce a transitive dependency into our database. Our key is student ID, course ID, and term. That determines the grade, as it should, but now there's also a dependency that grade determines points. If we would be normalizing fully, we would pull the grade and the point out to a separate table, but for the purpose of demonstrating aggregate functions, we'll just leave them in, even though that does mean that we'll have some unnecessary complexity in our database. And at this point we can start crafting our query. So let's see what it takes to implement those changes. First, we want to alter the table at grades, and we're going to just add a column called points, and that is of the data type float. So if I look again at my table grades, we see that it now has been added as an extra field here. At this point we can start doing some simple updates. We can, for example, start doing things like update points, update grades, set points equals 4, where grade equals A. There were no records in this case, but this is how you would do it. So we have a B, that would be 3 points. Still, I don't think I have any grades left in here. No, so that would be why. But this is how we would update our database, and at that point we can start building our query. So what are we looking for? Well, we're looking for the average grade. So we can start pulling that out, but we're actually not looking for the average grade, we're looking for the average number of points. And we're looking for the average number of points per course ID. From what? Well, from courses. From grades. So where term equals fall 2019, because that was the restriction that we put on there. And at this point we have basically all the grades issued in fall 19, and we can start grouping them by what? Well, by course ID. And at that point order by average descending. Now of course there was nothing in my database, but this is how we would go about building that query. Notice that this would just give us the course ID and the average number of points. If we want to have the real grade in there, we'll have to learn how to do nested queries or joins. We'll get to that in the next section of this video. We've now seen how aggregate functions can be used to apply these roll-up functions to groupings of data in a database. That means that we can now not only store and retrieve data in the database, but we can also enrich that data, at least somewhat, in the database itself without having to first pull it into a computer program that does all of our operations for us. So select from where. As normal, first I limit yourself to the data that you want to analyze, then the group by function, followed by the order by for the output. If you think about it that way for your aggregate functions, they shouldn't be too difficult. In the next video, we'll look at how we create queries that spin multiple tables.